Let's go to packages and go to data sets. Look for data sets. Yes, so you click on it, and there are so many data sets here. So within your field, you may go through it and you may find something. So this is, I think, psychology. This is air miles. That's like transportation. Air passenger, also transportation. Air quality, it could be physics or, yeah, something like that. New York air quality index. So maybe we can look at this. So you see, air quality, what do I see? The format, it is all a data frame with all 153 observations on 6 variables. So it means that this one, we have how many rows? 153. How many columns? 6. Is everybody okay with this? Yeah, so these are all data sets that you can look at. Hello? Yes. Yes, evening. David, me try this over. Okay. So if we continue to go through it, there are so many you have some within your area. This is journal, ball attenuation data, attitude, price, attitude data. There's a quarterly time series of number of Australian residents. You go to Beaver 2, Beavers, BJ6, a whole lot. Okay, and these are real data sets from different experiments and so forth. And they have references to it. So let's say if you use it for your project, you will be able to cite it as well, which is also accepted. Okay, so take your time and go through it. You may find some that will be of interest to you. Okay. So let's just look at the one that I looked at was what is the ozone, right? Let's see. It's the air quality data. So let's look at it. Let's play with it a bit. So it says daily air quality data. If you are into air quality data like those are physics, you know maybe some relationship or some methods of estimating some of the variables and so forth, that there may be some statistical implications that you may want to look at. Okay. But for me, we can just explore. So there's even examples here. We can look at it. So pairs, you can copy what is there at the examples. So pairs will plot, yes, like it looks like this. So it requires, once you say require, it means that the available package is just like load, right? So if we just run air quality, this is what we will have on our screen. Remember, it was 153 and then 6 variables. So when you come up here, you will see the ozone, solar, wind, temperature, month, day. Okay. So what we are going to do is to look at the pairs. Will just do plots of what? Each, let's say ozone against solar R, ozone against wind, ozone against temperature, ozone against month, ozone, and then it will take solar against wind. So we'll look at the relationship between all these variables. That's what that example is about. And now, because I'll not get a good graph because I have increased my font so much so that but you will see it better. Yeah, so you see, so look over here. You see, I can't plot because my plotting area is so small because I've increased my font size, but you will be able to plot. So just go, I can decrease this and plot it. But if you see error in plotting, your margins too large, it means you don't have enough space to get your plot. So please take note of that. So if I want to do it, I need to, because this, I'll get a 6 here, so it looks like this. Okay, so just copy. So when we look at this, we'll be able to know the relationship between the variables. Okay, so that's case. When we get to plot, these are some of it. So let's all plot it. At least we can do some description of it. No, you need to go to the air quality data. So just do question mark. take a look at one of the graphs and explain it to us. So the first one, you see there is solar. So ozone and solar, these are their, but it's the same thing, right? Turn upside down. Look at this one. It's the same thing here. Because here is ozone and what? So here, ozone is on the y-axis. Solar is on what? The x-axis. But when you come here, solar is on what? The y-axis. Ozone is what? The x-axis. That's why, so if you turn it around, it's the same thing. Okay, so this graph, we can take out the, it's like what we call it's a triangular matrix, right? Whether the top or down is the same. So when I take this, it's the same as this one. This is ozone. The last one is what? Ozone and what? Day, right? That's it. It's the same as what is over here. Is that okay? So it's more or less like we can have a line of a diagonal matrix, right? So that's a diagonal. And then what is over here is the same as what is. It's just like when you have covariance matrix. Later on you'll be doing all this. So yeah, so when we take this, it's the same as that. So what can we say about the relationship between ozone and solar? What happens? When we want to study what happens, you look at when one is increasing, what happens to the other one? Okay, so later on you'll be doing correlation and so if we all increase together, then there is some positive correlation between them. What it means is that if we are decreasing, we all decrease together. It's just like when you are doing investment. We say don't put all your eggs in one basket, right? It's the same principle they use. If you, let's say, invest in only the financial sector, okay, then 2017 when they started collapsing banks and others, then you are in trouble. Because all your investments are over there. So, you know, if they pick up, if you are losing, you lose massively. If you are gaining, you gain massively. So that's a positive correlation. So if there is a negative correlation, then it means that as one increases, we expect the other to decrease. Which means when one is decreasing, we expect the other to increase. So usually when you are doing investment in finance, that's the principle they use. Okay, such that, you know, when there is any shake-up in the economy, as one is decreasing, the other is also increasing to offset the losses you make. That's portfolio management, what they used to do so. Okay. So if you look at this one, that's opposite what we just observed. Look at ozone and wind. You see here, as ozone is increasing, what happens to the wind? Sorry, ozone is the y-axis. So as wind speed is increasing, what happens to the ozone measurement? So I think if I am here, this is the value. If I increase, of course, when you are going to the right, you are increasing, right? Yeah, so if we take a point over here, right, that is more than this one. So what happens to the value of the ozone? It's decreasing. So this is a form of a negative correlation. As one is increasing, the other is decreasing. When we come over here, what happens? Wind speed is decreasing. What happens to the ozone? It goes up. So that's what we say. It's more or less an inverse relationship or a negative relationship or correlation between them. What about this? Ozone and temperature. It's positive, yeah. As the temperature is increasing, the ozone measurement also does increases. So we can look at this. Later on, you'll be doing regression. And so for multiple regression, simple regression, and so forth. These are some of the things we will be using to check whether there is a relationship between. Is there any question on this? But this is stored as what? A data frame. So that's why we are learning the basis of all this, so that you'll be able to store your data and be able to analyze it. But we'll come back to this when we are doing multiple regression. So if our interest is in ozone measurement, we'll be checking. Then it means all these will be some covariates that are helping us to predict ozone. If that is the case, in statistics we say that these ones, because they are independent variables, they should not be correlated. So if you have heard of multicollinearity and so forth, that's what we are talking about here. So if solar and wind are predicting ozone, right? If solar and wind are predicting ozone, then I don't expect solar to be related to what? Wind. If there is that relationship between solar and wind, then their effect will be confounded. One will be in the other. Yeah, and so. So we will treat all those things as multicollinearity. We will check. One way is to drop one, because what you are, the influence on ozone is also, if we drop it, it is still being hated for the other variable. So we'll be doing all those things as we move on. Okay. Any question? Any question? So we shouldn't lose track of what we are doing is the data types, but we must bring in all this so that you know the essence of why we are doing all this. Okay. The data frames. Okay. What else? Okay, let me talk about it. If you look at solar and day is this, and then, okay, let's say even day and solar and day, what will be the relationship? There's no relationship. Yes, it's already scattered around. So that is what we will require of our independent variable. Okay, if they are not related like this, then if they are all predicting something, you don't, there's no overlap between them. Yeah, that's all we'll be looking for when we are doing regression later on. So we may come back to this same data and use it to construct some model to predict ozone. Okay, all right. Okay, so at least we've seen a bit of correlation now, and we can move on. Okay, so let me talk about another thing, then I'll come back to how we can select observations from data. So we'll come back to this data. So I want to talk about the last one, which is a list. We won't use them that much, but it is important that you know so that you can use it to organize your data later on. Okay. Now, remember that these ones, they are all, if I'm using data frame, it means if I have two variables, they should have the same number of data. Why am I saying so? If I look over here, age, it has 1, 2, 3, right? 1, 2, 3. So we call this rectangular data, right? So if I take this one off, it ceases to be a rectangle. Which means if you have a data like that, it cannot be stored in now as a data frame or a matrix. Okay. One way to go around this is that we can put in what we call the missing value. So, I don't know, did I talk about data types the last time? Did I write it? No, I didn't. Okay, but now we know what numeric data is. At least we've seen what an integer is and so forth. And we've seen characters, right? Because when we created our variables, we saw that some were characters. Okay. There are others, So the types, the data types are this. So we have the structure and the type. The types are within the structure. So what will constitute the structure is what we term the types. Okay. So we can have our data types. Data types. But I've talked about the quantitative, qualitative, we've talked about that. Good, okay. So the data type 1, we have numeric. This numeric includes integer. It's anything that is quantitative. Is that okay? All right, so we've seen all that. Then 2, we have character or character. So the character data is like these ones. Female, those ones and so forth. We'll come back and look at them. So character. Then 3, we have what we call, okay, let me start with missing values. So, as I was just saying, we went to collect data, but this person did not want to tell us about his or her salary. Which means if we give papers out, when they come, this place will be empty. Right? So what do? If we don't put in a number, we cannot store the data as a data frame in R. So what we do is to provide it with what we call missing value in R. And that means you write NA. So R actually uses NA as what? Missing value. Okay. So what we'll do is that when we do this, we'll provide NA over here. So whenever you see NA, it's a data type. It's something that we can use to fill this. Okay. Then 4, we have factor. So a factor is like you remember your scale of measurement. When you have qualitative data, this scale of measurement can be nominal or ordinal. The nominal is just groups. So we talk about our sex, we can group ourselves into male and female. Okay. But if we want to talk about the level of students in the university, then we also have groups, level 100, level 200, level 300, level 400, 600, 700. But even though they are in groups, if you take a level 700 student, you know that they have spent more years at the university than what? Level 100. So now when they are groups with what? Order attached to it, that's ordinal. Or the grades we get in an examination. Okay. The stage of someone's cancer, diabetes, and so forth. So they have stages and so. So let's say if you have cancer and you are with that stage, they can say, well, you have some few days or some few months. So that's nominal. So factor allows us to implement that. So which means that when we take a character, we can now use factor to now group them either into order groups, or just groups. Yes.
So the missing values, is there any calculation behind it? Done in the R2?
Yes. So later on, you see, if let's say we have this and we are computing the average salary, we cannot include this person, because if we include that person, we don't have data for him. But remember that the mean you divide by the total number of people. And so if you include this person, it will decrease your mean. Meanwhile, your average salary is high because you have added one person without it. So later on, when we are computing a mean, we'll be checking whether NA is in. If NA is in, we will omit it. If we will omit it, means the sample size will reduce. But instead of 3, we'll have 2. That's it. So it's important that we know about this. And it's one of the data types that helps us to maintain the structure of the data. You know, this is computer, so it's not flexible like a human being. So if you do this, it must come in this form, other than that it won't. it won't work. Okay. So that's it about factor. So factor, it will help us to get nominal and what? Ordinal data. Ordinal data. Then 5, we can have dates stroke time. So you may be dealing with data that has time. It's time. Every day, maybe rainfall pattern in Ghana. So you go and collect data from 1950 to now. Okay, to have data. So so if you type date, it will display today's date on your screen. And the time as well. Okay, so date and time are also a data type in that. And then lastly, what else? Missing value factor dates. Yes, yeah, thank you. Logicals, yeah. And then we have what we call logicals. So the logicals are true or false. I also understand what true and false is. But the true must be written in capital. And the false must also be in capital. So T, capital T is also recognized as true, and capital F is also recognized as true or false. So it means that because that is from when you are naming your objects, you should not be using T. And the small t is also to transpose a matrix. Yeah, so the T, the big T, the small t, you cannot use it to name your object. We can add some characters to it so that it changes the name. But just the small t, it means if you have, let's say, if we have this, and we put it in small t, it will change it in such a way that we will have 3 columns and how many rows? 1, 2, 3, 4. So if you do, it will change rows to become columns and then columns to become rows. So that's the logical as well. So R recognizes all these as data types that we can use to form a structure of the data. Okay. So that's, yes.
Does it mean that the operation of the logical is always a binomial?
Yes. Yeah. So it's just true or false. So here it's just true or false. So we either have true like this, which is also we can denote it as T, and also false, which we can use capital F to also represent. If you add, we can add them, even though they are logical. So the true is assigned 1, the false is assigned 0. Okay. So for example, if I'm doing polling and I ask you, will you vote for MPP? And it is true. Okay, so I have to put a statement that you will vote for MPP. Then this man's answer may be true, the next man's answer may be false, and so forth. So when I finish and I add, or I find the mean, that will give me the proportion of people who will vote for that person. Because the yes will be the true, and then the no's will be on the false. So if I divide the total number, I divide the number of people who vote or said true by the total number of people, that will give me the proportion of those who will vote for that particular party. We will take a look at some of this when we get to hypothesis testing to check or to understand some of the polls they will be doing and what are the things you need to ask of if somebody gives you like poll resources. So, yes. Yes.
Like when we run it just shows up like all the data. Is there a way the coding can be seen, or the coding before this, like to get this?
Yes.
Is there a way R can show that to you?
When you say the coding,
That so
that with functions. But the data sets, you can't really see what code gives you. It's just stored. But if you call, for example, plot, you see we use pairs, so to speak. We have used pairs now. And then we put in some arguments, and then we got a graph. That pairs, there are some, we can demonstrate it to you. There are some like codes that somebody have done behind the scene. Yeah, that constitute that. But we'll get to functions later on, and then we see how we can even do our own function. But if you usually take a function like this, and so that's it. When you are using pairs, that is what is behind it. But there's a method. This one you won't see it properly, but when we get, I can show you some of them. Let me see if I can show you. Okay, so let me see. Okay, so not this. Just a moment. Okay, so let's see. You won't understand, but it's just to show you something. So this is some work that I'm doing. So let's say this. When you are calling it, you will just call cn fun. So whatever is inside here, you won't know what is it. So this is what we call the function. I can go on. There's also fn fun. So we will get to functions, and then I'll show you all this. But some can be very long, okay, like this, and so forth. Yeah. So, but for data sets, nothing. But all the functions we'll be calling, they have some hidden stuff within it, and there are some that we will take and modify it to suit what we want to do, and we'll show that later on when we get to functions. Any question? Okay. So let's move on to talk about the list. Don't worry so much. As I said, you won't really use this. In some cases, it may be needed. So let's just look at it and say list. Okay. So in R, what do we mean by a list? Remember that I said it is of this type, right? It's one dimensional. But this one can have that one and so forth. Okay. So let's go to our environment and see, have you loaded the credit card data and so forth? Have you been able to load it into our? Okay. So the data, I can put the data here, even though it's 3,000. Okay. The next one, I can put, let's say, DF data, and so forth. So I can put anything that I want in this once it is a list. But I can't do so if it is a data frame. So that's the flexibility you get with a list. Yeah. So let's see. So let's look at it. So you call it you get a name for it. Let's say my list. So that will be a list. This is how we do it. You just give the function to create it is called list, but small letters, right? Okay. So the first one. So you see the credit. That one I can't display. It's true. There are 30,000 observations. Okay, so it means that, so credit, I can say is a credit card. So my first object is credit card. That's a data frame made up of what? 30,000 observations. Okay. The next one, what other variables have we? We have a religion, right? That's a vector. Okay, so this, what should I just say data? Let's say, so this is a data frame. So I'm just naming it so that you know that you can put a data frame in. You can put this one in. Okay, so that's a data frame. Okay, then next, I have a vector. vector, I even have character, right? So the vector character is all religion. Remember, religion is a vector, but it's a character, right? What else can we put there? Weight. We did also weight, which is what? Numeric, right? Okay, so just to show you that you can put anything in what? In a list. So num is equal to weight. What else can we put in? Do we have a matrix? Yes, we have a matrix. I have math.data. I don't know whether you have that one or math1. Which one do you have? All of them. If you use what we did last week, this should be in. Okay, so all what I'm doing is to collect different data types or data structures and put it under a list. That's all. Okay, so let me put in matrix, and I think that should. And we can also have even a list within another list, and so forth. So is that flexible for us? So let me call it math.data. If you don't have what I'm doing in your environment, when you run it, you'll get an error. Okay? So all what I'm saying is that if you want a matrix, just take any matrix over there. Once it is there, you can coerce it into your list. So if I do this, I can run it. You see my list is showing over here. It says it's a large list. So because of that 30,000 observations, it's that large enough. It constitutes about 4 elements. Okay, so I can click on it again, and then it shows me. The first one is a data frame, right? And it consists of 30,000 or no, 25 variables. The next one is just a character vector, 5 of them. The next one is a numeric, double, and it's 5 of them. And then the matrix is double 5 times, so 2, which is 5 rows and 2 columns. That's all. So that's it with a list. Okay. And yeah, so once you are done with this, I want us to go to the air quality data. We want to see how we can select observations when we have a database. Is everybody okay? Yeah. So, yeah. Complex data in that. So it can contain different data types, different and the credit cards. So you set credit cards, so you have to go here and check whether you have credit cards. Before, so you named it before it's too long. So this is what you have to put to work. So when you start it, where is your data? So instead of credit, you have to start and say all so now you can place it. Is everybody okay? Later on, when we see a list, we should know that it's the most complex data set in our data structure in our. It can contain any data type. However, it does it just like what? A vector. It puts the first observation here, the next observation there, and so on. Is everybody okay? All right. So now I'm going to go through another concept. Let me show you the structures. I have explained it, but let's see. We will see some later on. Okay. Let's look at what we called subscripting. Before subscripting, I have explained these ones. Yeah, so we will get some in practical situations. Subscripting with data structures. Don't worry about the title. It is just subscripting, or okay, let me put it, or selecting. It doesn't work that way. Subscripting with data structures. Okay, so what do we mean by this? I need to increase the font size so you can see. What we mean by this is that when we have a data set, sometimes we need to select some either observations or variables. Okay, so let's go to the ozone data set that we use. The ozone data set is what? The data frame, right?
Air quality.
It's air quality, yeah. So it's a data frame. Once it is a data frame, then it means it is updated from rectangular. Okay. So if I'm interested in only ages of people, how do I get it? If I'm interested in only age and religion, how do I get it? Or if I want to select, let's say, Ahmed's data, how do I get it? Please, you get what I'm saying now? Yes, we have a big data, but you may be interested in only one variable, or maybe two, or you want to select all female and analyze their data, or all male, or all people who are over 50 years. Do you know what I'm saying? That's what we term subscripting. And we can do so in a vector, we can do so in a matrix, we can do so in a data frame, and also a list. So, because this is an applied course, I don't want to be going into the details, so I'm just going through where you have some practical aspects, and then we can move on. So let's see. We have the air quality, yeah. So let's look at air quality data again. So we do question mark and then look at it. Okay. So it says, it's New York air quality data, right? So we know that this one is about all. Then we look at the data format. It says it's what? 17. When we finish, we are going to do the data we read ourselves. So that it's not like some abstract data somewhere. Okay. So it has ozone. So you see, ozone is the first column, right? So you see that here, it is showing you that it is what? You have square bracket, because it is this. We usually, when we want to get something from it, we will use it. So you need the name, then you have this square bracket. Now there's a comma here. Now anything here is for the rows, and then any observation here is for what? Columns. Is that okay? The columns are variables, the rows are what? Observations. Okay. So if you look over there, this, we have You see, before the comma is for the rows. Do we have anything there? There's no number. If there's no number, it means we are selecting every row. Okay. But if you select all the rows, you are only selecting all the first column. Okay, so let's display the air quality data. Sorry. So let me do this and then so there it is. So you see, ozone is in the first column. Okay. So what we are going to do is that if we want to study only the ozone, we can copy this. So let's say I do a comment and I say select ozone data only. Then what do I have to do? I have to call air quality data. Then I put this sign over there, and then I put 1. So there are several ways we can get this. 3 ways, so I'm going to do all of them. This is okay when you have data set that have not many variables, right? Then you can refer to them with numbers. But if you have so many, you can't be going in to be checking where is it 20 feet. Then it means you have to count 1, 2, 3 up to 25. So this is 1. So if we run this, you see, we only get, you see N is in there. So it means that for such maybe towns or so within New York, they did not report the ozone data. But it has the other data, so you don't discard all of them. Yeah, and then so that's the missing data that we've seen. So this data is only for what? Ozone. Because we took what? The first column. Is everybody okay with this? Okay. Now, what if I want the first number for the ozone data? Then I can put, remember, before that is row, right? So I'll be interested in only row 1. So I can put 1 and 1 like this. It's just to get me what? The first data. If I want the 10th, I'll put 10 and 1 and so forth. So that's how we can retrieve data from it. So that's one way. But remember that, as I said, you cannot be counting, especially if, let's say, you want to get the number 100. Okay? We can also get it, that's the 100th ozone, this thing as 89. But you don't need to be doing that. We can also use the names of the columns or the rows to do it. So this same thing, I could have also obtained it by not using the 1, but I go and copy the ozone, the name of the ozone, then I put it in quotation marks. Okay, so ozone. You see, I'm copying, I'm not writing it on my own. Because the ozone, the O is what? Capital. If you make it small, you get an error. And so forth. So usually you should cultivate the habit of what? Just, so I can get the same thing. So let me run this and run that. You see, it's 89, 89. Yeah. So you can also select using what? The name.
Why is the 1 there?
Because the first column.
The one in the brackets here, in the results.
The
one in the bracket.
In the results.
This one.
After, no.
Oh, okay. That will give you the position of the value on that. So let me go back to this one. You see this? So it helps you to count easily. So if you check over here, we have 10. So this is the first, second, third, and so forth. That's the 11th.
Yes, so that one continues.
Yes, it continues.
Why you select only one data item?
Okay,
Like
so
the one you selected right now.
yeah, so if it is 1, only 1 will
Only
count.
one is giving you, okay.
It is telling you that you have only 1 observation there. But this one we have, you see, I think it's 153. So you see 151, 152, 153. Other than that, it will be difficult for, remember we got 100. So I can get 100 observation. You see, it's here. So it helps you to count quite easily when you are on the console.
So if I were to select 3 items,
yes,
the square bracket would be 3.
no,
It still be 1.
it still be 1, but I will talk about that soon. Yeah, I'll talk about it. Please, are we okay? Are we okay? So let's all select. I want you to select the data for, let's see, there's solar. Okay, so what about solar.r? How can we select all the data for solar.r? We've talked about 2 ways of selecting the data before I move to the third one. Yes. 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 2. Okay, that's 1. What else? Yes.
Instead of the 2, replace it with solar data.
Good. Yeah. So if we want to do this, we can follow the same thing we did over here. We copy, we paste, then we call air quality, and then solar is what? 2, but that is the column. If I bring 2 before the comma, it means the second row. That will give you only the second observation. So the other way around is that we also take this, right? And then what do? We solar, you can copy. If I'm doing it, I usually will copy because it saves time, and then yeah, like this. So if we do any of this, we are going to get the same observation. I can even put them together, and you realize that they will be the same. So C bind means column, add the columns. So I can put these 2 inside the C bind. I provide it with a comma, then I do this. You see, they are the same, isn't it? Isn't it? You see 2 columns, each of them is the same. So what this is showing us is that these 2 gives us what? The same result, whichever one you use. Yes?
The last time we were doing the tables,
Yes.
we referenced the columns using the
Dollar.
That's in the dollar sign.
We will do that as well. It works with this as well. Yeah. It works with it. So that's the third one I'll talk about. Okay. So let me just add that one. Okay. So alternatively, we can also select, but that is only for the variables. You cannot select the rows with it. Okay. So another way is that we can also call air quality. Then we put the dollars, and it will provide us with all the variables. Then we select which one are we interested in? Solar. So any of these 3 is okay. All right. This is good. This is also good. I don't, the numbers, it's when the data is small. If you have small number of columns, it's okay. But there's no need to be counting maybe 40. If you have 40 variables, then maybe 25. You are now going to count 1, 2, 3. I mean, it's not advisable. Yeah. Yes, please.
So I thought we were dealing with the ozone. That's what it says, select ozone layer on ozone data only. I thought we were about dealing with the
Oh, sorry, solar. Yes, thank you. I just copied. That's also, when you copy, you have to also be careful. It's just like those who do ChatGPT. They will send us assignment. They say, this one I don't know. I don't understand this one. that is part of it. Somebody was also writing a letter. The letter is ChatGPT. You say, insert your name here. Students are lazy these days. So insert your name here, sign, and it's going. Okay. Yeah, so when you are copying, you have to be careful. Okay. So that's it with. But let's look at other things. Let's look at the ozone. So the air quality, we have wind speed, right? We know that wind can also cause problems, right? Like what happened in US recently. So what if we are interested in wind speed? So let me get quanta. Okay. So let's assume that wind speed over 18 causes massive destruction. So I want us to be able to select, let's say, the observations that has what more than 18 wind speed.
Yesterday we saw that quantiles is not, I mean, these are actually quartiles.
Yes.
So why the function, you are calling it just
Quantiles.
Then,
Okay, so you see, when you have data, you can divide it into several. If you arrange it, you can divide it into 4. If you divide it into 4, it is called quartiles. If you divide it into 10, it is called deciles. If you divide it into 100, it's called percentiles. But we can generalize it for any. So I can have 3 data sets. I have 3 people who give me your ages. I can divide that 3 data into 200 parts. It doesn't make sense, but that's it. That's how.
So why does this give us only?
So this one, it gives us only the.
parts?
Yes. So the 0 is just minimum, and then the 100% is what the maximum.
So why does it give us just 5? Are we?
We can let it give us as many as we. But by default, it gives us this. If you want more, you can add it, and then it will get it. But this one, I just wanted to see what. Something so that we can work with it. Okay. So what I'm saying is that wind speed over 18, the wind speed is measured in what? In miles per hour. So we are assuming that if wind speed is more than 18, it causes destruction. So let's say if you are at an insurance company and they bring you this data, you want to see what is the proportion, okay, of these days, or what is days, right? So they are measuring days and months. So what is the proportion that have what? Wind speed over 18? How do we obtain this? Which means not all of them are over 18, right? So what are we going to do?
No, sorry.
Yes.
I tried to run the same command. I have NA12.
Which one? This one?
Yes.
The quantum?
Yes.
Okay, so that was to aid me to get a value that I want to use for the example. Because your wind is small, you type, you did not select. Your wind, the W is small letter, but this one is capital. Okay. So, my question is, we want to solve this question. What days have wind speed, or how many or proportion how many days wind speed over 18 mph. Please, are we all on the same page? We have wind speed data and ozone measurement, air quality, right? But let's say if the wind speed is over 18, it causes maybe the air quality to be not good, people are going to hospital and so forth. So you want to plan ahead, right? Then you need to know the past data, how many days, or what is the proportion of days that you have wind speed over 18. Then you can plan. Here, then you can budget for that fire service. And it is election year, then that will go everywhere. Okay, so that's what the extent of some of these stuff. Okay. So how do we do this? Well, remember that we can get what? The wind speed, right? So we'll just take the wind speed data, that will be a long vector, and then we check which ones, when we say greater than 18, it will give us that logicals we talked about. If it is greater than 18, it will be true. If it is less than 18, false. Are we all okay? Okay, so let's try and do it. So now you have to select wind speed. How do you select wind speed? Air quality, $sign, wind. Good, okay. So do not type, right? So you just, do not, when you use the $sign, don't type. You have to select so that you don't make mistakes. So wind speed, right? Okay. So this one, if we run this, it is going to display all the wind speed on the console. Okay. Now, if you look through, which one is over 18? You can find some. Or it was two. There's 20.1. Okay. So you see that it will be only small, but so greater than 18. If I do this, I expect those that are greater than it to be all true, and those less than it to be all false. Okay. So let's do it. Okay. So you see, false, 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 false. Only a few. So true. There's one over there. Maybe they are about 3 or I think only 1. 2. Okay. Yeah. Okay. So if I want to count, there are 3. Good. If I want to count, I can. So let me do it like this. Count. If I want to count, what should I do? Good. So we will sum. So count of wins, air quality wins be greater than this. We are going to do a sum of this. And the sum gave us 3, which means only 3 observations are on greater than 18.
You don't want to lose.
Oh, just now. Don't I have 2 hours? Me too. Okay, let's finish this one. Okay. So you see, we've gotten 3. So what is the proportion? It means we need to know the total number of wind speed, the number of the data, and then we divide it by 3. We divide that one by 3. So I can then move on to talk about proportion. Proportion of wind speed over 18 mph. So in that case, what I'll do is that I'll find the length of the vector, okay, which is just like the sample size. So we can use length, or if you go back to the data, we can count the number of rows. We know it to be 153, isn't it? Yeah, but we need to program it to do so. So what we can do is just say we call this the sum, and then we divide by what? We divide by just the win, this one. So this one is all of them. So I can select only this, the length, and run it. You see it's 153. Okay, so if I do this and I run the two, I'm going to get this. So the proportion is about 0.019. And for proportions, it's easy to report it in what? Percentages, right? Yeah. So if it is percentages, what do? I multiply this by what? 100. So instead of proportion, I'm going to say percentage of wind speed over 18. So this is, I take the same thing, copy, and paste over here, and I multiply it by what? 100. And there we go. So this is 1.96%. So less than 2%, if we want to talk about it, then we'll say that less than 2% of the days are done. Wind speed over 18. So then you can now plan towards it. Yes. Yeah. You had an error. So please, I'll give you the one to find it. So 1.96% or less than 2%. If we are reporting, so you may write the same report, but I am using less than this. Somebody is using what? Exactly the same number, or approximately 2%, something like that. That's how we will be looking at some of these. Any question? So please, when you go, please make sure you can read the data I sent you into it. Explore. Ask questions on some of the data set. So for example, the credit card, we have so many of them. Okay. We can select equal to. So look at this. The sex, we have 1 and 2. Okay, if you go back to what we did, maybe the site, it will tell maybe male is 1 and then female is 2, right? So we can select all those who are 2, all those who are what? 1. Age. So from what we have done, you can check the proportion of customers who are, let's say, over 60. Okay, or you want to check how many of the customers or credit card customers were less than 30 years, or even between. Okay, and so forth. Yeah, and then we can check, for example, their balance. Later on, we'll be checking whether there's a relationship between education and your limit, okay, and so forth. I think there was default. Is it default? Do we have? Yes, there's default status too. We will be checking whether those who defaulted, their credit card balances were more than those who did not default. We want to check whether the high debt leads to default. Sometimes there are those who owe small but they don't pay, and so forth. Yeah. So we just have to be, answering questions on this. But when we are doing this and you have any problem, whether from the workplace or whatever, you can anonymize it, right? And then we can discuss it. Yeah, so, or redact it, whatever you want to do it. Anonymize it, you can change even the names and everything, the names of the columns. And all we need to do is just some practical aspect to look at it. And then there was another one. I think there were 2 data sets. The other one was on. Unless we check on your. I put 2 data sets over there. So make sure that you can read all of them and just explore some of them. Because the next time when we meet, I'm just going into plot. We want to see how we can plot so that we can get, I don't want us to be doing theoretical stuff, but just plot. We'll start with, remember last week we did a bar plot, right? Yeah, so we'll now start with categorical. So when we come, the default status, we will check how many defaulted, okay? So we can check some of those. So for example, we use tablet, and then I can check credit cards. I put the $sign, I go down, I go to default status. Okay, so I can check. Oh, what happened? Oh, it's not. I need to check. Maybe it's not. Okay, yeah, I didn't. Instead of table, I did. So it means that 6,636 of them defaulted. Right. I can express this in percentage by dividing by the sum, just like we did. Okay, so just like what we did, I now table this, and then I know those who defaulted. Those who did not default was many, right? Okay, so if I want to report on this, I can report on this with a bar chart or a pie chart, okay, or a plot, a dot plot, just one dot over there, and so forth. Okay, so that's what we'll be doing. If we have any data set, how do you get descriptive statistics to look at it? Then when we are done, we now go into the descriptive, but the numerical descriptives. So the mean, the median, the mode, as you are learning over there, we are also taking all of them and taking practical data sets like this and checking each of them and so forth. Okay, so that's the next thing we will be doing. Okay, so Prof is not coming. Or maybe he's waiting that I step out. I'm also waiting that he comes and bail me out. Okay, so if I divide by this, you see I get, sum, let me check this, sum of the default status, 6 no, it's 0. So I must rather count the length, I should say, length. Yeah, so, and then if I multiply by 100, I get it in percentages. Okay, so we can say that approximately 22% of the customers defaulted in paying their credit card debt, and almost 78% actually will pay. But we will take each of these and look at, we can compare them with the educational level that will we'll go into chi-square test to check whether there is a relationship between your default status and your educational level. So we'll be doing all these things as you do. You go through your hypothesis testing as well. Okay, so I think we'll meet tomorrow, right?
Yes.
It's what, 5? Is it 5:30, right? Okay, and when I come 5:30, they will say I should wait. Okay, so I'll see you next time, tomorrow, God willing. So I'll just send you the